Hello all, in this session we are going to understand two more important terms in statistics. One is covariance and one more is correlation. What is it with this correlation and covariance? This covariance, when you talk about covariance, it is going to tell you the relationship in between two variables in a data set. Let us take x and y. If x is changing, how y is changing? What is the impact of the change in x on y is called covariance. If x is increasing, what is happening to y? How strong is this relationship? Is it positive or negative? That exactly is the covariance. How y is being affected. Rather, if y is changing, how x is being affected. That is what? The covariance. What is the correlation? Correlation actually is going to quantify this covariance. Once again, what is the correlation? Correlation is going to quantify this relationship. How strong is the relationship? And at the same time, it also quantifies the direction. The total direction will be confined in between -1 and 1. It just is going to quantify this in between -1 and 1. So let us understand this by using a simple example. For this, I just have taken a data set. What is the data set? That data set is an example data set which holds two arrays. One is maths and science. These are the scores of a boy with respect to his maths and science in a single academic calendar year. These are the math scores and these are the science scores. Now let us understand how the covariance is going to be calculated. In order to calculate the covariance, the first step is we need to take the mean of both maths and science. What is the mean? Mean of the maths will be total score divided by total scores divided by total number of scores. Total score is something, total number of scores is equal to 5. So the mean of the maths is equal to 83.8. Mean of science is equal to 82.6. Now what is covariance? Covariance meaning we should be able to multiply the deviation of means of each variable and add them. And we need to take the average. That is what a covariance. In the simplest terms, as I would tell you, it is average of sum of products of variables. Okay, so the average is n. Sum meaning these are the deviation. Xi minus mean will give you one deviation with respect to maths. Yi minus mean will give you the mean of one variable with respect to science. We are going to multiply this. The total addition, the total sum of all these products, when you divide by n, is going to give you the total covariance. For this, let us calculate the covariance completely. Now let us take the product for each independent term. Now, in the first step, what I did is, I calculate the mean of the first variable in the maths. Here, this is the mean of first variable in the science. What is the mean? You take the first variable, you just subtract it from, the mean should be subtracted from the first variable. The first variable is 85, the mean is 83.8. Here with respect to science, this is the science, right? With respect to science, the mean is 82.6 should be subtracted from the variable 80. When you multiply them, you just are going to get minus 3.12. Okay, this is the first product, this is the second product, third product, fourth product and the fifth product. When you add them together and divide it by the total number of data points, you are going to get the covariance. Now just 134.6 is the sum of the product of all the deviations. This is the sum of the product of all the deviations, and this is average of sum of the products of all the deviations. 134.6 should be divided by 5. This is the average of sum of the products of all the deviation. This is 26.92. In this case, for these two data sets, the covariance in between the scores of maths and the science is equal to 26.92. It's a strong covariance. That means both science score and maths score are tightly coupled with each other. If there is increase in the math score, there also is an increase in the substantial, strong increase in the science score, and also the vice versa. This is what? The covariance. Now, what is correlation? Correlation is the simplest term. Right after you understand the covariance, correlation is not a biggest deal, because in the correlation, initially we will compute the covariance. This covariance will be divided by standard deviation of x into standard deviation of y. How would we do it? We already knew what is the standard deviation. What is the standard deviation? Standard deviation is equal to square root of variance. Okay, what is variance? If you do recall, what is the variance? Variance is average of sum of squared deviations. Right? We already understood about the variance, how to calculate the variance in the previous session. The variance is average of sum of the squared deviations. So in order to calculate the standard deviation, first of all we need to get the variance. What is the variance here? Variance of maths will be equal to, when you plot this, variance of maths will be equal to 36.16. And a variance of then the standard deviation of the maths. What is standard deviation of maths? Standard deviation of maths is the square root of the variance. The square root of the variance of 36.16 is equal to 6.01. 6.01 is the standard deviation of the maths. Similarly, when you calculate it for science, the standard deviation of the science will come to 5.12. That is because initially variance has to be computed. Variance is the sum of the squared deviations. These are all the squared deviations. And when you divide it with 5, you are going to get the variance. This is the variance. Right then, standard deviation is the square root of the variance. 26.24, if you square root this, you just are going to get 5.12. Now we calculated standard deviation of x, that is maths, standard deviation of y with respect to science. Now correlation is, how do we get a correlation? Correlation, R is equal to covariation of x and y divided by standard deviation of x into standard deviation of y. What is the covariation of x and y? Covariation of x and y, already we got that, it is 26.92. It should be divided with standard deviation of x, which is 6.01, into standard deviation of y, which is equal to 5.12. So 26.92 divided by 6.01 into 5.12 is equal to 30.78, which actually identically is equal to 0.874. 0.874 is the measure of the correlation. If you actually can understand this, this 0.874 is in between -1 to +1. This is very close to 1. That means that there is a strong bond in between the variables of maths and with the variables of the science. If it is going negative, if it is going in the negative direction, when one variable is increasing, other variable will get decreased. That is how the correlation is going to quantify the relationship in between two variables. Yeah, these are the formulas of the covariation in a nutshell. Yeah, that's it from the session. Thank you.